Hey YouTube family, Namaste. I hope that all of you are very fine. This is Subrodebnath and I welcome all of you to my channel Bengal Bro Tutorial. Welcome to the fifth lecture of the chapter Electric Charges and Fields. Students, in the previous lecture we learned about Coulomb's law, deduced its expression in the vector form and then finally learned how to define the SI unit of charge. And in this lecture we are going to learn about the range of coulombic forces and then try to make a comparison between the electrostatic and gravitational force and finally conclude today's class with the principle of superposition. But before we start the class, just a small bit of information for those who are new to this channel. Students, you all can easily avail the lecture notes from the link given in the description box. Also, if you have any doubt regarding today's class, you can feel free to ask me in the comment section. Alright, so without any further delay, let's start today's class with the first topic, range of coulombic forces. Means, now we are going to look at the minimum distance that has to be there between 2 point charges for coulombic forces to act between them, as well as the maximum distance of separation over which coulombic forces can act between 2 point charges. And if we talk about the minimum distance, then it is 10 to the power minus 15 meter, which is almost equal to the order of diameter of nucleus. Understood? Which means that the 2 point charges, say Q1 and Q2, has to be at least separated by a distance which is equal to 10 to the power minus 15 meter. Now I am sure many of you are wondering what will happen if the distance of separation between them is less than 10 to the power minus 15 meter. Then in such a case, the strong nuclear force will dominate over the electrostatic force. Now, the strong nuclear force is attractive in nature, unlike coulombic forces which may be attractive as well as repulsive. In case of like charges, the coulombic force between them will be repulsive in nature, and in case of unlike charges, the coulombic force will be attractive in nature. But the strong nuclear force is attractive in nature. And it is charge independent, means it will not depend on the type of charge, because it is always attractive for any kind of charges. Now, this is the reason why a large number of protons having like charges can stay within the nucleus without getting repelled, because when the protons as well as when the neutrons are within the nucleus, then the distance of separation between them is less than 10 to the power minus 15 meter, and that's why coulombic force don't act between them. It is the strong nuclear force which acts between them and holds them together within the nucleus of an atom. Understood? So this was the minimum range of coulombic forces, and the maximum range over which coulombic force can act between 2 point charge is as large as of the order of 10 to the power 18 meter. It is the maximum range. Understood? So the maximum distance between 2 point charges over which coulombic forces can act is of the order of 10 to the power 18 meter. So we can say that coulombic forces can act over an enormous range of separation from microscopic distance equal to 10 to the power minus 15 meter to over macroscopic distance as large as 10 to the power 18 meter. So that's all about the range of coulombic forces. Now let's try to make a comparison between the electrostatic force and the gravitational force. The expression for the electrostatic force between 2 point charges can be given as F equals to K Q1 Q2 by R square. Here K is known as the electrostatic force constant. Q1 and Q2 are the magnitude of charge of the 2 point charges and R is the distance of separation between them. And the expression for the gravitational force between two masses can be given as F equals to G m1 m2 by R square. Here G is known as the universal gravitational constant. m1 and m2 are the masses of the two bodies and R is the distance of separation between the two masses. So first of all, let us look at the similarities between these two forces. If you carefully look at both these expressions, then you will find that both the electrostatic force as well as the gravitational force are inversely proportional to R square, which means that the electrostatic force is inversely proportional to the square of the distance between the 2 point charges and gravitational force is inversely proportional to the square of the distance between the 2 point masses. So we can say that both the forces obey inverse square law. Both forces obey inverse square law, which means that both the expressions are inversely proportional to the square of the distance. Now the second similarity between the two forces is that both are central forces. Which means that both these forces act along the line joining the centers of the two bodies. In case of electrostatic force, if we consider 2 point charges, say Q1 and Q2, separated by a distance r, then the electrostatic force between them will act along this line which is joining their centers, and if they are like charges, then the direction of force will be away from the two charge, and if they are unlike charges, then the direction of force will be towards the two charges. And if we talk about gravitational force and consider two masses m1 and m2 separated by a distance r, then the gravitational force between them will act along this line and will be towards the two masses, because gravitational force is attractive in nature. So this is the meaning of central force, means a force that acts along the line joining the centers of the two bodies. And both the electrostatic force as well as gravitational force are central forces. The third similarity between the two forces is that both forces can operate in vacuum. Which means that the electrostatic force between 2 point charges can act on each other even if there is no medium between the 2 point charges. Also, the gravitational force between 2 point masses can act between them even if there is no medium between the two charges. So, both can operate in vacuum. And the last similarity between the two forces is that both forces are conservative in nature. Both forces are conservative in nature. which means that the work done by these forces is path independent. The work done by these forces on any body will depend on the initial and final position of the two bodies and will not depend on which path the body is going through. So, this is the meaning of conservative nature of any force. So, these were the four similarities between the two forces, and now let us look at the differences between the electrostatic force and gravitational force. So, one difference I hope you all can guess very easily. The electrostatic force between two point charges may be attractive or repulsive in nature depending upon the nature of the two point charges, but the gravitational force between two masses is always attractive in nature. So, this is the first point of difference. Electrostatic force may be attractive or repulsive in nature. But gravitational force is always attractive in nature. Now, the second point of difference between the two forces is that the electrostatic force is medium dependent. It depends upon the medium between the two point charges, because the electrostatic force constant is medium dependent. But in case of gravitational force, it is independent of the medium between the two point charges, because gravitational force is constant and does not depend upon the nature of medium between the two point charges. So, we can say that electrostatic force depends upon the medium between the two point charges, whereas gravitational force is medium independent. It means that if we change the medium between the two point charges, then the electrostatic force between them will also change. But if we change the medium between any two masses, then the gravitational force between them will not change. Alright. So, the last point of difference between the two forces is that the electrostatic forces are much stronger than gravitational forces. The electrostatic forces are stronger when compared to the gravitational forces. Let me give you a practical example so that you can realize that the electrostatic forces are really much stronger when compared to the gravitational forces. See, if you charge a plastic scale and bring it near bits of paper placed on table, then you will find that these paper pieces are getting attracted towards this charged scale. Now, there are two forces acting on these bits of paper. The first force is the gravitational force due to the earth, and the second force is the electrostatic force due to this charged scale. But in spite of the two forces acting in the opposite direction, the bits of paper will actually get attracted towards the plastic scale, which means that it is moving in the direction of electrostatic force, thus giving us a proof that the electrostatic forces are much stronger compared to the gravitational force. Understood? Okay. So now let us look at the principle of superposition. While the Coulomb's law gives the expression to find the force between two point charges, the superposition principle enables us to find the net force acting on a charge due to a number of point charges. First, let us consider n point charges. Say Q1, Q2 and so on up to Qn. Now each of these charge will experience a net force due to all other charges. So if we have to find the net force on any of these charge, say Q1, then we have to take the help of the superposition principle. Now according to this principle, the net force acting on a point charge will be equal to the vector sum of all the individual forces acting on this charge. So the net force acting on charge Q1 will be equal to the vector sum of all the forces acting on this charge Q1 due to all other charges. So we can write F1 is equal to force on 1 due to charge Q2, force on 1 due to charge Q3 and so on up to force on 1 due to charge Qn. Okay, one thing you have to note that if I ask you what is the force between the charges Q1 and Q2, then the coulombic force between them will not change due to the presence of other charges. This point you have to keep in mind. Now from Coulomb's law we can write that do you remember that F12 can be written as 1 by 4 pi epsilon naught Q1 Q2 by mod of R12 square into R12 cap. F13 can be written as 1 by 4 pi epsilon naught Q1 Q3 by mod of R13 square into R13 cap, and F1n can be written as 1 by 4 pi epsilon naught q1 qn by mod of r1n square into r1n cap. Okay. So, if we want to condense this whole formula, then we can write that the net force on charge q1 is equal to q1 by 4 pi epsilon naught. I am taking q1 common from all this individual expression. So, we can say that F1 equals to q1 by 4 pi epsilon naught summation over I is equal to 2 to n qi by mod of r1I square into r1I cap. Here we have to change this value of I from 2 to n and then keep adding them to get the net force acting on charge q1 due to all other charges. So, this is the expression for the net force acting on any charge due to a number of charges. Alright. So, that's all for today. Hoping to see you very soon in another video. Till then, stay safe, keep studying and have a wonderful day ahead. Goodbye.